This is page 26. We are looking at writing systems of linear inequalities. So this paper has 5 problems on it total. The first one you will see is very detailed. The first one's very detailed in the way it's laying out all of the information. And then the second one, there's a little less details. And then if you go to the back, there's even fewer details. So this first one is showing you all the steps involved. And then it's asking you to try second, third, fourth, fifth. Okay, everybody with me? Yeah. You okay? All right. We're writing the system of linear inequalities. We want to call her Blanca or Beyonce?
Beyonce. Beyonce has the best video.
It's clearly Blanca. I will say, as you're reading word problems, okay, if you ever come to a name you cannot pronounce, don't get caught up on the name. You're in the business of trying to answer the question correctly, right? It's just a test, like on the EOC. So don't let the name distract you and then confuse you. So what I tend to do is, if it's a name I cannot pronounce, because I know I'm supposed to be focused on the math, not the person, then I'll just call him by the first letter. B. B works at a drive-in movie, and so that's a trick if you're taking a test and there's a name. I do it also in books when I'm reading. If I cannot pronounce it, I'll just call him by the first letter until I can figure it out. All right. So Blanca works at a drive-in movie in the ticket booth. The drive-in has a small parking lot. So it has a maximum of 300 tickets and charges $7.50 for adults and $5.50 for children. She expects to collect at least $1,500 for each. Okay? Focus. If you go back to the FAIR question from yesterday, the FAIR question about the rides and games, they told us what X was and what Y was. In this question, we have not been told what X and Y are. So that means we have to define them ourselves. I always define it in the order that the problem reads it. So what 2 things do we have going on here? We got X and Y. And in the word problem, what 2 objects are we talking about, or items?
Tickets.
What type of tickets?
Children and adult tickets.
All right, so I'm going to let X be the adult tickets, and I'm going to let Y be the children tickets, okay? So X is the number of adult tickets. Y is the number of child tickets. Not really sure what's going on with the board. All right. Now we're going to write our inequalities. Now, close it. You should be on this sheet. Guys, please focus. I am recording. We're going to write 2 inequalities to represent this situation. This is what's going to be helpful with your Delta math. I need you to understand that your 2 inequalities, one of them is going to be referring to money, and the other one is going to refer to quantity, like if I was just counting. Okay? There's a difference. One is value, money. One is quantity, how many total. You with me?
Yeah.
If you can wrap your mind around that, it makes writing the inequalities easier, okay? The money one is the easiest one to write. The money inequality is the easiest one because you're going to literally go to the picture and you're going to pull just the money numbers, okay? What do all the money numbers have? What symbol?
Dollar sign.
Dollar sign. That's why the money one is the easiest one to set up first, okay? So looking up here, we need to account for the price of each adult ticket and each child ticket. All right, tell me what to write to represent each adult ticket.
7.50.
And do I really have to write the zero here? Not really. X, okay,
5.5.
very good. All right. And then now you need to go to your word problem and figure out what is the other money value, the other money number, and what kind of inequality sign are we working with here? It says she's expecting to collect at least, which means, can she collect 1,500? Yes. Wait a minute. She wants to go over, like she can go, so greater than or equal to. Y'all, please stop. All right. So this inequality represents money. Okay? Everything in there is money. Now we're going to do an inequality that represents counting up the number of tickets. So the next one is going to be the tickets. Not the cost of them, but like counting them. All right, so what type of tickets do we have again?
Adult and children.
Okay, and what are our variables for adult? X, and what about Y? No, the variable for child ticket is so we got X plus Y. If I was trying to count up how many tickets, are you focused right here? If I was trying to count up how many tickets, it'd be X plus Y. And then look at your word problem. Do we have a constraint on the number of tickets?
Yes.
300. The facility only holds, you're good, 300. So what type of inequality would represent having a max capacity of 300? How many could we sell? Could we sell 300? Yes. Could we sell more than? No. No. Less than?
Yes.
So less than or equal to 300. And then now what you're going to do, and this is probably the hardest part, is putting it on a graph on your own. Now you can go to Desmos and you can type these in. You will have to adjust your Desmos screen to find it. These are bigger numbers than we've been dealing with. So you will have to adjust your screen to find it. Let me pull that up. Come on, y'all. I feel like only half of you are listening. I'm going to pull it up on Desmos and show you how to adjust. Okay, second. What was the next one?
X plus Y.
Okay, so when you first graph it, you can't see anything. You have to zoom out. You come over here and zoom out. And then now you can start to see where our graph is. Which quadrant am I interested in? I'm only interested in the first quadrant. Why? That's where our solution region is, but that's also, we're talking about what here? What are we talking about? Feasible region, but what type of numbers are we allowed to use here? Positive whole numbers, because we're talking about selling tickets, okay? Really, I didn't see it. I'm recording. All right, we're going to copy this to our paper, okay? What you need to do is pay attention to the x-axis and the y-axis to get the numbers. So you can see on the x-axis, there's a point right there and here. So we've got 200 and 300. On the y-axis, we've got 300, and then this point right here, we can use Desmos to tell us what that point is. And it looks like it's, no, I do, I gotta drag this. It looks like it's 0.272. 0.272. So, can I leave it there? There we go. So we're going to go to our graph, and we're going to scale it in a way that we can reach 300 and 300, okay? You wouldn't have to do this on the EOC, so I'm going to help you with this part. But it is good for you to practice with number sense. I'm going to count by 50s, but I'm only going to label, what did I label? I'm going to label, what did I count by on else? 25? Yeah. I'm going to count by 25, but I'm only going to label every other one. So it looks like I'm counting by 50s, but I'm really not. All right, and then X was our number of adult tickets. Number of adult tickets. Y was our number of child tickets. I'm going to count this the same way, every other one. Okay. We said copying from Delta Math, or not Delta Math, Desmos. Come on. We've got 200, the red line is 200 to 272. So I'm going to go here and put a point at 200, and then a point about 272, and draw my line. Next, I've got 300 to 300. So 300 to 300, and then do the best I can. I can give you a ruler if you want a ruler. All right. This is our feasible region. We don't want to shade the entire picture because then it's going to throw us off. We only want to shade the feasible region. Feasible region is the overlap, okay? It's the overlap of the shaded regions. So if you look, this is my feasible region, all of this through here, okay? That's what you want to copy to your paper because that's your solution area. And then now we can answer these questions. It says, if 150 adults and 180 children attend, is this a solution to the system? 2 ways to check this. What's the fastest way to check it? Double check your X and Y's. We did say X is adult and Y is children, so they are telling me this is adult and this is children. So we're checking 150 and 180. You can go to Desmos, and you can actually type this coordinate point. I'm going to tell it, what did we say, 150 and 180? Well, it was me, but none of it took. Why is it not? Oh. There we go. I'm sorry. All right. 150, comma, 180. And then enter. Label. Look where 150, 180 appears. Is it in your feasible region? No, it is not a solution. It is in a shaded region, but it's not the double layer, which is the feasible region. So we would come over here and we would say no, not a solution. Now I need you to check 175 and 105. Check 175 and 105 right now. You should be looking at Desmos, checking this solution. What? What'd you get? 175, 105.
Yes.
Yes, it is a solution, which means you could sell 175 adult tickets and 105 child tickets. All right, let's come down here and do this next one together. A seafood restaurant owner orders salmon and tuna. Salmon's $3 per pound and tuna's $4 per pound. The owner needs to buy 50 pounds of fish for the week, but he has a budget of $240. What do you think we're going to assign X and Y to? And 4. Very good. So I'm going to assign it in the order it presented. Salmon is 3 per pound, that's my X. Tuna is 4 per pound, that's my Y. So X is going to be pounds of salmon. It may help to put that it's $3 each, right? I'm going to put 3E because E stands for each. And then Y is pounds of tuna, and it's how much? How much? 4 each. Now we're going to write our 2 inequalities. We're going to write one for money and one for counting your total pounds. I want you to write one for money and one for the pounds of fish. So if you would, please leave. All right, write your inequalities. Jackson has my charger, and I'm sure his is. All right, write your inequality for money. This is great. You have one small problem, and it's the inequality for your count. Needs 50 pounds. So what would needs 50 pounds mean? He's literally telling me. Can be equal to, what else can it be? Do not check your phone. It could be equal to, or it could be Which one, greater or less?
Some is
Can he get more than 50 or less than 50? If it says he needs 50, it says he needs to buy 50, so can he get 50? Yes. What else could he get? More. If he gets less than 50, has he met the requirement of needing 50? Goes to this one. If he gets less than 50, has he met the requirement of needing 50? Watch this foot, please.
Is it that with the one?
It will, yeah. All right, so what was your money inequality?
3x plus 4y.
So 3x plus 4y. He has a budget of 240. Can he spend 240? Yes. What else could he spend? Less than. So, I told you the money one's the easiest. Now you're tallying up how many pounds in general. So what would this be? And I heard it over here, x plus y. Now he needs 50.
Greater than.
Good. He needs 50, which means he can get 50. He could get more than 50. He cannot get less than 50. All right, so now we're going to graph this on Desmos, okay? We're going to go to Desmos and we're going to see where these numbers intersect the x-axis. All right, what do we get? 3x plus 4y. You should be, I know, but you should be working. Is less than or equal to 240? Then we got x plus y is greater than or equal to 50. And I don't like these colors. I don't do red and black. Don't know me. It's not going. No, Georgia can't stand it.
I agree with that.
Guys, can y'all please get that, if I see that picture again, I'm gonna get really mad. It's not funny anymore. All right, watch out, sorry. Okay, we're gonna copy this information over to our picture. What's your step? So this line is crossing at 50 and 50, and the other one's crossing at 80 and 60. So we need to be able to count our marks. I think I counted by tens. I counted by tens. So 10. I'm going to count every other one though. This is 20, 30, 40, 50, 60, 80, 90, 100. All right, 10, 20, 40, 60, 80, 100. Let's label our axis as well. We said X is pounds of salmon. We said Y is pounds of tuna. Coming back to Desmos, because Desmos is going to tell me these numbers. The first line I need to draw is going to be from 50 and 50. Those are the intercepts. X-intercepts 50, Y-intercepts 50. So 50, 50, and I'm going to do my best to draw a line. My next one, X-intercepts 80, Y-intercept is 60. 80 and 60. So the way I'm getting my numbers to plot it on my paper. Now remember, on the EOC, I don't see them having you plot by hand. I can see them giving you a graph and saying which graph is correct. But they're not gonna give you a blank graph and say, you need to fill this in, you know what I mean? They can't grade that.
Yeah.
But this is at 50, this is at 80, this is 50, and 60. Those are the numbers I'm looking at. If those numbers were ugly, then I would try to find a pretty number somewhere and plot it instead. But these numbers ended up being pretty. Feasible region is that double layer, so that's what we're going to copy to our paper. We're going to copy this as our feasible region, right here. Notice it's always underneath. All these real-world applications we're doing so far, it's always like the feasible region is right there in the middle, where one was going up and one's going down. Now we're going to check these possible scenarios. If the owner buys 20 pounds of salmon and 40 pounds of tuna, is that a solution? What about 15 pounds of salmon and 50 pounds of tuna? Do not answer out loud. I need everybody to answer these two questions on your own right now. Did you find that 20 and 40 was in a solution region? That's because 2040 is right here. Definitely in the region. And then what about 1550? 1550, judging by my graph, it's kind of hard to tell. This is why you want Desmos, okay? You could also algebraically prove that it doesn't work here. If you plug this in, that's X, that's Y. If you plug it into the inequality, this would be 45 plus 200, that's 245. Is that less than or equal to 240? No. So that's your algebraic reasoning, okay? So I can see the state saying, hey, it's not enough to be able to say yes or no. Explain why not. You would say because this would read 245 is less or equal to 240, and that's a false statement, okay? All right, go to the back. I want you to do the back. Numbers 2 and 3. I'm going to tell you number 4 has a small trick. Watch out for number 4. Here we go. What does this mean? Right here. He tells you to buy 2 Bob Dylan records, right? Let me start you on number 4. A record store is going out of business. They're selling posters and records. Your dad gives you $45 or $60 and tells you to buy 2 Bob Dylan records. What does your paper say? How much money? $3.99. Okay. All right. So we've got X movie posters and Y records. X is going to be our number of posters, and Y is our number of records. But what did your dad tell you he wants you to buy? What did he say? What does your dad tell you to buy? What's it say?
2 Bob Dylan records.
Okay, so 2 Bob Dylan records. What else could you get him?
3 Bob Dylan
You
records.
could get him 3. And did it say anything about posters? So your first inequality is going to be money, but your second inequality is going to be what your dad has asked you to make sure and get. And that is, he said, definitely get me 2 Bob Dylan posters, but did you get more? Yeah. do you think our money inequality would be? How much is it? $3.99 X, $8.99 Y. What's your budget? Which means you could spend less than or equal to 60. All right.